Assalamualaikum and good day, student. Welcome back to the distant learning. We will mainly cover on the part 3 of chapter 4, which is focused on the friction on the clutch topic. Okay, then what is clutch actually? If you see from this figure here, you can see that there is an input shaft attached together with a disc, and then on the right hand side another disc is attached to the shaft. At this situation over here, when the disc is disengaged, so there is no rotation that could be transferred from the input shaft to the output shaft. However, when we apply force from either output shaft or on the input shaft, so let's say in this case we apply a force from the output shaft towards the input shaft, so both discs will engage, so saying it's meaning that the clutch is in engaged mode. So here what we can say is that the rotational speed over here at the input shaft is also being transferred to the output shaft. Also, the moment or couple is also being transferred to the output shaft because of the friction that occurred over here. So actually, clutch is a device that used to connect and disconnect two coaxial rotating shafts. So that is when there is an engagement by pressing the disc together with the axial forces F, the shaft rotate and can support a couple of M due to friction forces between the discs. Now we will look into the type of clutches available. So mainly there is two types in general, which is a positive clutch and friction clutch that we are going to focus more. So the the positive clutch, as you can see here, so this is example number 1, the square jaw clutch. So when you see on the picture over here, it seems like there is a manual interlocking whenever you want to engage or disengage the pair of clutch over here. So you have to either pull or push this manual lever over here. So same applied to the spiral jaw clutch. So this is a mechanical clutch that you need to stop the operation of machine, either to engage or disengage the clutches. Alright, let's see on the friction clutch over here. So we have under the category of friction clutch, they have a friction clutch with a plate or disc, friction clutch with a which is a cone clutch. Another one is a centrifugal clutch. This is a typical friction plate clutch or plate or disc clutch. Actually, this is the friction material that be available at the single plate clutch. So it's either made from Kevlar or ceramic that have its individual coefficient of friction to enable the friction occur between the both pairs of this when it's engaged together. So what is a single plate clutch? This is the figure of a single plate clutch, whereas this is the figure of multiple plate clutch. The difference between single plate clutch and multiple plate clutch is only the number of friction plate that has been installed over here. So this is only one friction plate is being installed, whereas if you see at this picture, there is 3 unit of friction plate has been installed over here. So that make the difference between single plate and multiple plate clutch. What about the cone clutch? If you see over here, the arrangement of a plate clutch is slightly different because of the conical shape that has been designed over here. This suit the purpose of a heavy duty application vehicle that could be transferred more torque by using the cone clutch. Compared to the centrifugal clutch, so if you see the centrifugal clutch mechanism over here, the driving shaft is being attached together by a spring with this is like say the friction material over here. So this is the housing. At a predetermined speed of the driving shaft, the friction material here will also rotate and create a centrifugal effect and move towards the housing. So this is the housing of the friction plate housing. So the friction material over here will attach to the housing over here, and at the same time it could drive the driven shaft. So any torque that occur over here or rotational can be transferred to the another shaft over here. So basically that is the type of clutches, whereas this one is a bit a comparison between the positive clutch and the friction clutch. So this could only be the engagement and disengagement of the positive clutch could only be done by stopping the machine. Compared to the friction clutches, the engagement and disengagement could be done during the machine in the operational mode. The merits for the positive clutch is a bit simple and low cost. No slip will be occurred and no heat generated during the operational, compared to the friction clutch, where of course there is a heat generated at the in between the surface of the connection here because of the friction, because of the two pairs connecting together. So there is a heat generated over here, but anyhow we could get a smooth engagement due to a gradual increase in normal force. So this is how our some of our vehicles works on the clutch plate. Okay, let's see a bit on how the clutch work, in our vehicle. So the center one is the this is the clutch. Actually, this is the clutch mechanism. This is the lever to engage and disengage the clutch, whereas on the left hand side is our engine bay, and then on the right hand side is our gearbox. So in any time when the clutch is in disengaged mode, so meaning that the rotational or torque that is being produced by the engine could not be transferred to the gearbox. When the engagement is been activated, or when the engagement of the clutch is been activated at this clutch system, so all the rotational and torque of the produced by the engine easily can be transferred to the gear. Okay, all right. So this is a single plate clutch with a dual side effective. What is the meaning of dual side effective? If you see from this picture over here, so this is basically from the engine, and then over here is towards the gearbox. So basically this is the friction plate. So dual side effective plates, meaning that so this section facing to us is also effective on the friction, and then on the back side also, another surface that is effective, meaning there is a two surface, the two surface of connection, a pairs of a connection with a two plate. I mean, not two plate, it's a single plate, but with two surface of a connection. So facing to us, connect to the surface, the disc at the diaphragm spring. The other side is connected to the flywheel over here. So if you imagine that if we compress together this plate at the diaphragm spring over here, and then at the flywheel we compress at the friction plate over here, so easily we can transfer any torque produced at the engine over here towards the gearbox over here. Okay, this is another sketch that could easily understand on the dual side effective. So this is from engine, this is to gearbox. So from engine, that is connected, there is a disc over here, and then there is another disc at the engine over here. This is the friction plate, both side effective. The red color means on the right hand side also there is a friction material, on the left hand side also is a friction material. So that is two contact area, two effective contact area, and within this a single plate clutch. This is the actuation lever, the contact lever to either engage or disengage the plate. Okay, this is the multiple plate clutch, the typical multiple plate clutch. So just now we are talking about single plate. So this is the first plate, this is second plate, this is third plate for the friction material plate. So this is a friction material plate 1, 2, and then this is a friction material 3. Whereas this is the disc, the metal disc. So inside also have another one here. You cannot see it. So here there is another one over here. So there is 1, 2, 3, 4, 5 plates, and then this is the this one actually no, this one is actually here. This is the one because it's already dismantled. So this is 1, 2, 3, 4 for the iron disc, for the metal disc, whereas this is the friction material over here. So actually there is 6 contact surfaces, 1, 2, 3, 4, 5 and 6. So this is the example of the multiple plate clutch. Okay, that's all. Thank you very much.